Nothing better to start the day than with some Seattle grunge. Yeah. Thank you all for coming out here today. It's amazing to see all of you here. I hope that by the end of the day we have shown you that there is an old world of IT, and that old world of IT is dark and gloomy, and you're locked in. And there's this new world of IT, yeah, where you are in control, where you decide what your vendors do, how they behave, and if they're not doing their job, that you should be allowed to walk away and choose other services. This is our strong belief. This is what we believe, how our vision of being the Earth's most customer-centric company, which you can imagine is easily applicable to the way that we do retail, how that also applies to Amazon as a technology and as a service provider. Yeah? We should be continuously on our toes to give you the absolute best service. The new world of IT is where you are in control, not your vendor. And that's actually really that I hope that if you walk away today, if you go away, that sticks in your mind, that Amazon is a very, very different technology provider, where we really want to be your partner, not your vendor. Yeah, where we actually want to help you drive your costs down. If at the end of the day we can actually help you reduce your bill with us, that would be fine. Because we believe that if we help you save cost, move faster, that you will be a customer of us for a very long time. And that's where we'll be focusing on. So my talk this morning is just to be the glue. Yeah, I'm just glue between 4 customers that are actually here today. Yeah, News Limited, Brandscreen, Vodafone Hutchison, and realestate.com.au. They are all customers on this platform. They will tell you some of their experiences. Why did they move? How did they move? What is their focus with using cloud computing? And after that, after my talk, you'll have Steve Smith. And believe me, everybody would think that security is a boring topic. Yeah? Steve will make this as interesting as that you have ever seen. It is an amazing presentation that he gives. Please, start thinking about security as something that will help you, that will actually be at the base of each of your architectures, and that will allow you to serve your customers much better. Steve does an amazing job on that. So with that, it's actually my task just to give you a bit of the state of the art. So what we've done in the past year and a half, we are now at 8 regions around the world. Last one that we launched for the general public was in South America. And our goal is eventually to color in most of these geographies around the world with low latency access to any of our regions. Yeah, so hundreds of thousands of businesses around the world, 190 different countries, if I remember well. This is just a very small sliver of probably some of the tools that you use online. But just as much large enterprises are moving pretty rapidly into the cloud. And not just with proof of concepts or things like that, or just dev and test. They are really moving significant production systems into the cloud and actually seeing both cost savings as well as a lot of agility there. Probably in the past days you've heard quite a bit about our partnership with both Oracle as well as SAP, where most of SAP's core systems are now certified for production on top of AWS. And that's one of the larger enterprises in the world actually is the federal government in the US. And they are an example of what we see happening around the world where governments are realizing that if they start using cloud technologies, they can actually get programs in the hands of their citizens much faster, while at the same time saving significant money. And the US government has a cloud-first strategy that is working really well, and more than 100 agencies of the US federal government are now using Amazon's Web Services to deliver services to their customers. Yeah, and the great thing is they have all these beautiful seals, and I'm collecting those seals now. Yeah. And of course, the nicest one is the one NASA at the bottom. Who wouldn't want to work for NASA? Everyone's dream. Yeah? NASA will come back in my presentation later this afternoon as well when we talk about large-scale data gathering and analytics. please stick around for that one. Important for us is that the Amazon cloud is a lot more than just Amazon. Just a lot more than just the Amazon Web Services. Our ecosystem with many of our partners, both in the system integration space as well as in the ISV space, is just incredibly important because just servers, just data storage is not enough by itself. Yeah, you need to do something with it. And the functionality on top of that can be delivered by many of our partners who have all sorts of products that are actually really targeted towards the cloud. Even companies like Oracle, who you may have thought of as not necessarily being as big promoters of the cloud as people may have thought in the past, they are excellent partners here where many of our products such as e-business suite and things like that are really ready to be used in multiple availability zones and things like that. So the same goes for companies like SAP and Microsoft and others. So what are enterprises actually doing? Yeah, and I think these are sort of the broad 4 categories. I actually think there's a 5th category, but I'll get to that. Of course, there's just traditional business applications that enterprises are running in the cloud. I don't know if you were in here earlier, but if you saw the quotes coming by, Shell is a major user of our services. And the main reason why they picked actually cloud services from AWS for their core IT infrastructure is because they want to move faster. Yeah, this is a story that you will hear a lot. Most of our customers, or certainly most of our enterprise customers, are coming on board first with an idea of cost savings. But pretty quickly they will tell you that the real reason why they're in the cloud is because they are becoming more agile. That from a situation where their IT organization was seen as the blocker, they can move to a situation where the IT organization is seen as the enabler of innovation. Yeah, and that is a major shift. Yeah? The old world, the dark and gloomy world, where IT is even not consulted anymore by business units if they need to start doing new projects because they know they're going to hear no. Anyway, yeah, and it wouldn't be the first time that I hear the word stealth cloud mentioned, where business units actually go out themselves and acquire resources from cloud providers, not even talking to the IT department anymore. Moving to a new world where the IT provider or the IT group is actually the one that brings these cloud services inside. They help them vet security, they help them vet reliability, they help monitor, and all these kind of things, and make sure that the business units can move as fast as possible. Lionsgate on that, on the top list, actually runs 27 SAP installations. About 2/3 of those run on AWS. And there's a whole range of that. Samsung sits more in the category of web application. Samsung's display division, these smart TVs actually have a media hub associated with it, where you can get both third-party applications as well as access to all sorts of content. That media hub runs on AWS. Yeah, and when Samsung did the original specking of how that smart hub should look like, they did it on their own hardware first, but very quickly decided to go over to AWS because of the flexibility and the ability to scale. And actually their immediate cost savings were $34 million in CapEx and maintenance fees. Yeah? And here, this is an environment that needs to scale to unlimited heights. Yeah, because everybody will be watching TV at the same time and accessing content at the same moments. And so the scaling needs for that are tremendous. Big data is something that I'll come back to at the end of the day. There's a lot more to big data than just doing analytics, and I'll be talking about that. Enterprise is also doing quite a bit of disaster recovery and archiving. And there is a 4/5 actually bucket that is not on here, but where I'll be talking about later, is that of mobile in the enterprise. Yeah, there is a clear shift to having mobile workers being mobility enabled. And how to very quickly develop applications for that world is something that I see happening in quite a bit of enterprises, using cloud platforms to actually drive that development. Analysts have become aware that there are indeed hundreds of thousands of businesses using our services at this moment, and they put us all at pretty favorable positions in their quadrants. A metric that we use often to indicate a bit of the growth is the number of objects in Amazon S3, the simple storage service. We're now, at the end of last year, well over 762 billion objects in there, but much more important than those numbers is actually the trend line that you see here. The growth is really rapidly increasing. And from where I sit, I don't think we even have hit the knee of the hockey stick yet. That is something that still has to happen. And the acceleration that we'll see in the coming year to 2 years, especially driven by enterprises, is going to be significant. So we already looked at what happened at the end of the first quarter, and you really see that we're getting pretty close to 1 trillion objects in Amazon S3. Also, look at that other number, hidden somewhat at the left top corner, 650,000 storage transactions a second. Yeah? There is no other storage system out there that has that kind of capability and is actually able to scale to much more than that. There's a few things that I believe set Amazon as a provider apart from others. One of them is flexibility. The fact that you're able to run any operating system, any programming language, any middleware, any software, regardless of who the vendor is on our platform, often supported by those vendors themselves. You want to run Windows Server R 2012? No, that's not out yet. The whole range of the Microsoft Windows servers. Do you want to run Oracle's Linux? Do you want to run Red Hat Linux? Do you want to run SUSE? All of these supported by the vendors themselves. The choice is yours. And so we give you flexibility on that side. We also give you tremendous flexibility in the business model. Do you want to make commitments? Do you want to do pure pay-as-you-go? Do you want to use our auction mechanism, the spot market, to actually get very low cost capacity on a non-determined time frame? All of these options are available to you. You are in control. That's the mantra around flexibility. The second thing that sets Amazon aside is a relentless focus on price reduction. Something that you will continue to see us do in the future is actually drive the cost of these services down. And we've done that already 19 times since our beginning without any competitive pressure. Why? Because we believe that if you help us gain additional economies of scale, and if we work hard enough to actually do innovations that drive the cost down, and improve efficiencies within our platform, you should benefit from that. And so we've done that 19 times this year. We've done it twice already. First, we've done it in February, where we dropped our storage cost of Amazon S3. And with that, some of our customers saw a drop in their bill in February of more than 40%. And we lowered our compute costs in March, and some of our customers saw a drop of well over 30, sometimes 35% in their compute cost for March. We are happy to have you pay less with us, because it's all about the long term. We need to make you be successful in the long term, and with that, we need to help you minimize the bill with AWS while you can still enjoy using all these services. It's a core principle behind our company. Now let's look a little bit at the platform. We'll go through it pretty quickly. On one hand, there's the things at the bottom, the real physical infrastructure that we're building. The concepts there are regions, so they are isolated environments, different places in the world. There's about 8 of them now. Within a region, you'll have multiple availability zones. These are zones within each region that are isolated from each other, and that you can use as a programmable concept to build highly available applications. So an availability zone is a different building, sits in a stable flood zone, separate geographical, geological stable areas. They are connected to different power grids. They are connected to different tier 1 networks. All of these things make sure that they are as isolated from each other as possible in terms of the sense of failures, so that you can build great disaster recovery or disaster avoidance strategies. So then on top of that, there's sort of the network capabilities. Virtual private cloud is an extremely important concept within AWS, and we'll talk a lot about that later. I'll get to touch on it a little bit, but Steve Smith later on will actually go into great detail how this can help you secure your applications. Direct Connect allows you to directly connect to the cloud. We'll get to many of these kind of things. Yeah. Then we get to the usual building blocks, compute, with Amazon EC2 and auto-scaling and elastic load balancing, storage, which has Amazon Simple Storage Service, EBS as the block storage service for EC2, and something that you can run on-premise as well. Then there are databases, DynamoDB, Amazon RDS, which actually has a collection of different databases that they can manage for you. And then on top of that, there's a range of services that allow you to provide glue between the different pieces. Yeah, so the simple notification service, queuing service, workflow service, there's search there's emails, all of these kind of building blocks that normally would cause you significant pain if you would have to implement it yourself, and we'll be doing that for you. This is also an area where the ecosystem is extremely strong. And this is just a small sliver of a few different categories that we have that our partners are running on top of this platform. Then you get to the piece of sort of deployment and management and other applications there. We give you a range of different facilities. Identity and access management is a very important component there. You'll get to hear about that more later as well. And of course, the ecosystem is pretty rich here as well, with on one hand, companies that focus on management and bringing you into the cloud pretty quickly, but also doing sort of the platform programming levels. So the third thing that sets actually Amazon aside that, as a provider is our relentless focus on innovation. And the thing that actually Ed said earlier about feedback is extremely important. Yeah? We run a very agile methodology within Amazon. Each of our teams are responsible for connecting closely with all of their customers, listening very closely to their customers, and together with customers decide on what the roadmap for that service needs to be. And then very quickly roll out these new features or new services. That's often, and actually there's a great discussion with Richard this morning about what is some of the more complexity around AWS is the pace at which we deliver new services and new features, which can sometimes be daunting. But we're not believers in big marketing events where we'll suddenly show you the whole kitchen sink and then walk away from that. But what we allow our teams to do, that as soon as they have a feature ready, to get it in your hands as quickly as possible. That's the most important thing, so they can get feedback about whether they are building the right thing and in which direction their services should go. Now this is from the past years. This is what we did in the beginning of this year in terms of services already. Let me go through a few of them. Yeah, I think something that we just launched a few days ago is support in CloudFront, our CDN for dynamic content. Now you can use one distribution to cover both static content as well as dynamic content. And we do this in a way radically different from traditional CDNs. Yeah? What we believe is that the CDN should be that simple to use. Yeah? Not only from a business point of view, because I think that was one of the revolutionary pieces of CloudFront to start with, yeah, because nobody had a CDN that was purely pay-as-you-go. But we also believe that this should be a really simple CDN. With one click of a button, suddenly your content should be CDN enabled. And that works, you can imagine how that really works really well for static content, but we believe that we should be able to do the same thing for dynamic content as well. And we've done that. So the first steps are there, where you can just have one distribution with configurations for both static content as well as dynamic content, and with one click of a button you can enable that. Something related to the networking side is Direct Connect. Many of our customers have asked us that they do not want to rely on the general internet to access these capabilities in the cloud, so we give them tools to actually build direct connections into the cloud, either at 1 gigabit or at 10 gigabit speeds. Another thing that works on service, on-premise, actually is the Amazon Storage Gateway. Here we provide you with a virtual machine image that you can run on a node on-premise in your own data center or in your own cupboard. You can attach some disks to it. It can be either network attached storage or direct attached. Those disks will be created volumes on. You can back up those volumes into Amazon S3 and they are backed up as the EBS volumes. That means that you can either restore them just on premise if something would go wrong, or you can actually relaunch from them in the cloud by creating EBS volumes from them. It's a magic technique to very simply build very robust DR strategies. Another service that we launched, the Simple Workflow service in the beginning of this year, also has an on-premise component. The Workflow service doesn't only connect activities that sit in the cloud, they actually can also connect activities that run on-premise while other activities may be running in the cloud. DynamoDB is a magical piece of software that we delivered at the beginning of this year. The first NoSQL database that is available as a service, and I'll go into more details of that later. Also in the part of our whole database framework is what's called the relational database service. Here we manage standard off-the-shelf databases for you. You don't have to worry about what size to run, what disks to attach, how to keep them highly available. We run that for you. We started off with MySQL, and we had Singular's replication for MySQL, something that we built ourselves. But now for our Oracle databases, we also give you this multi-availability zone concept, which means that if there is ever a failure in one particular availability zone, this one will automatically fail over for you to the other availability zone. Very important concept. We give you containers. In this case, it's PHP and Git deployment. Quite handy because often you have some PHP content that you need to run somewhere. This makes it very easy to drag and drop that while you still have all control over the resources underneath them. And actually, coming back to the RDS framework, we now just launched SQL Server for RDS, which means that next to the choice of MySQL and Oracle, you now also have a choice for Microsoft SQL Server as a fully managed environment. And with that comes also support in Beanstalk for running .NET applications. So one of the last services that we launched was actually Amazon Cloud Search. And this seems like a bit of a, so why would you launch a search service? It turns out that almost every application, every website, everything that you almost build needs search. Everything has a search component. And you know what? If everybody has to do it, why does it need to be so terribly hard? Because if I talk to many of our customers, many of them are saying, well, you know, we have to, if you go the open source route, you have to install Lucene and Solar, and you have to configure it, and you have to scale it if the number of requests go up, or you have to scale it in a different dimension if your data sets are growing. And it requires quite a bit of expertise to actually keep this stuff up and running. Why does it need to be that hard? So we decided to launch a that simple cloud search service. You give us your documents, and we will make sure that we scale up in terms of the need. If your data sets grow, we scale up and down if the number of requests grow or shrink. And we also give you a whole set of different tools to actually manipulate the cloud search capabilities and cloud search results to your likings. To make sure that you would actually get an experience that is pretty close to the Amazon.com experience when you're buying software, we launched something called the AWS Marketplace. Here, many of our partners display their software to you. We have vetted that software for you. We vetted the payment models for you. We do the monitoring and tracking of that. But more importantly, you get the ability to look at what your peers are thinking about that particular piece of software. And if you don't like this software and you would like to run it, there is a one-click deployment button there. It is just like shopping on Amazon.com. If you find software that you would like to run in your environment, you click that button and instantly it will be deployed for you. So coming back to something I said earlier, there's a lot of a lot of things that have happened in the past year. One of the things that I'm particularly proud of is the new release of the virtual private cloud. Amazon Virtual Private Cloud allows you to cordon off a piece of the cloud and make it very easy for you to hook up services that run on-premise when run in the cloud. Why? Because if you cordon off this piece, all resources that you put inside that piece actually cannot communicate with the outside world if you desire so. Yeah, they can only communicate back over a VPN with your own data center. This makes your own data center elastic. It also makes it very easy to actually move resources between your data center and between the cloud. And actually, I would like to invite Greg Pendleton-Brown on stage, the CTO of News Limited, who will talk to us about how they are using VPC. Thank you.
Just picking up on a point that Werner was making earlier about old IT versus new IT. News Limited's been going through a major transformation. And over the last year, we've run a number of cloud-based projects. And what I'd like to share with you today is the most significant of those projects that we've been doing. To set the context, we run a single enterprise-wide content management system. It runs across 8 major websites, including websites like news.com.au, The Australian, Fox Sports. The ecosystem itself is made up of 12 critical systems, including our core CMS platform, which is FatWire, search platforms, video ingest platforms, content ingest platforms, as well as a kind of a whole delivery aspect. If on a monthly basis we generate over 600 million page impressions, that's equivalent to everybody in Australia reading more than 20 articles a month. And we create about 2,400 to 2,500 new assets every single day. What this creates is a huge challenge around complexity. To run up one single development environment, including all of these systems, takes 46 servers. If I was today to recreate production, it would cost over $1 million, and it would probably take about 67 to 70 different servers. The real challenge has been, in order to actually build one of these environments, the last time we did this, it took us 56 days from start to finish. And over 6 different teams to actually do that. So we end up with networking, security, infrastructure, development, operations, all having to get involved to try and build one of these environments. Our configuration and deployment has all been manual. So to give you a view, when we built this, one of our last environments, we documented all the individual steps that did that, and it turns out to be more than 300 pages worth of instructions. The impact, it's been really difficult for us to start up projects, just to get approval for a project. If you wanted to do some innovation, you're talking about getting some CapEx signed off, you're talking about a long lead time to get something started. When I joined about 12 months ago, we only had enough environments in our organization to run one significant project at a time. So we had to put pretty much all of our other big projects on hold while we ran one big project. The real thing that this leads to in our organization is a lack of innovation. For me to kick a project off or to try anything innovative and to run up any environment takes a huge amount of time, a huge amount of cost, and a huge amount of effort. So the challenge given to the team was to take this from 56 days and to get this down to 1 day in the cloud. Where are we? We've got our VPC set up. Werner was talking about that just a second ago. We've got that configured up and working. I've been really, really impressed. It really does just provide us as an extension to our on-campus data center. So you can be sitting anywhere in our building and access all of our systems up in the cloud completely seamlessly. We spent a lot of time separating out the configuration and repackaging all of our systems and looking at how we can deploy all of these automatically. It's pretty much taken those 300 pages worth of instructions and stepped down to a few push-button clicks to be able to deploy something. We now have a semi-automated deployment process. Where am I? Sorry, I've lost my slide. Semi-automated deployment process. And we've actually now got 2 projects up and running in EC2. And we've taken it from 56 days down to 3. Developers can now run up and tear down our environments automatically. Historically, You used to have to get operations involved, you have to get infrastructure involved. Literally now it's our developers that can do that. We've started 2 projects this month with proof of concepts up in the cloud. We've set up our whole environment to be able to stand up at any one point up to 8 development environments. I kind of had a question asked at one point, which was why the limit of 8? The reality is not everything that we do can automatically be done in the cloud. We still have things like our content delivery network and a number of other things that require manual configuration. So we've configured and set everything up to be able to run basically 8 projects at the same time. And by the end of this month, our real plan is to be able to reduce this down to 6 hours. So where to next? We've pushed really, really aggressively in terms of moving into the cloud. And what that's left us with as an organization is being a little bit on the back foot in terms of what the kind of overall corporate cloud governance model looks like for our organization. So we're spending a fair bit of time trying to document that, trying to sort through what does the licensing work, how do we make this, how do we get the operations working in the cloud, how do we separate out and make sure that what our developers are doing in one area aren't affecting production systems that we're putting up there as well. We're spending a lot of time looking at how we can automate so much of what we do so that we can go from being able to have a single push button deployment both internally into our own on-campus data centers and the same press button out into the cloud. The model of moving to the cloud has changed a lot of our projects from being CapEx-based to OpEx-based. And what that means is we needed to put a little bit more work and a bit of thinking around how we manage those costs for our projects. And we'd like to get to a really automated way of real-time being able to tell projects exactly how much it's costing for them to be running their projects and running up environments, as well as being able to start and stop those environments in a development perspective automatically. The projects forced us to get all of our teams working much closer together. And I've been really pleased and impressed with how our teams have managed to kind of pull together and work on this project. And actually, we've started this move down a DevOps model. And where I'd love to go is I'd love to just keep going down this. It's been a phenomenal transformation internally of getting all of our teams working really, really closely together. So in summary for me, I think we've achieved a huge amount over the last 6 months. We've gone from taking 56 days to create one environment down to 3 days, and ultimately being able to take that down to less than 1 business day. We've got a long way to go. Our next big challenge for me is taking our production systems and working out how we can get those up and running in the cloud. Thank you.
Actually, something that should help Greg, especially when we talk about automated control of cost, is that, and it wasn't on my slide deck, is that we just launched automated alarms for you around costing. Yeah, so before this, the way that you could access to information about your cost was not necessarily in a real-time fashion. Let's put it like that. You now have access to all running costs in real time, and that you're able to actually set alarms on particular costs rising, or just get good insight into what is on your daily cost basis or your real-time cost basis. So I talked earlier on about the old world of IT, and that we are working very hard to have AWS help you move into this new world of IT. And that's sort of where these 7 transformations come in. Yeah? These are all transformations from old world of IT to new world of IT. And most of those transformations actually are things we already knew we wanted to do, but were never able to do because we were stuck in this old world of managing physical resources and having these sort of standard old style procedures to go with that. Yeah, one thing, it's not just the fact that cloud computing is indeed about saving money. It does that. You know, the misconception is not here that that you're not saving money and that you're not becoming more agile. The misconception is that that's the only 2 things that are there. In the early days, when we launched these services, I had a sort of 4th button on here that would say 21st century architectures. And in those days, I had an inkling, had an idea what that would be, because I believe that our services will help you build architectures that are really part of sort of the new generation of how you build services. Things that are highly efficient, that are highly automated, that are securely built from the ground up. And all of these different concepts are in there in modern applications. But you could not build them in the world of old IT. Yeah, so cloud really helps you transform your applications from the old world of IT to the new one. So let's look at a number of them where this is evident. First and foremost, I like to start off with distributed architectures made easy. We have always known, and especially in my world, I come out of the world of research, computer science research. I was building all these wonderful algorithms, group communication, epidemic techniques, all of these things, building highly available factory floor automation systems, stuff like that. They were all extremely hard to do. We knew from a principle point of view how to build them, but actually implement them in reality was a nightmare. Yeah, and why? Because in the end, it was all about how to manage the hardware. How to get access to hardware, how to get access to hardware in multiple data centers, how to make sure you had networks between those data centers, how to do contracts with different network providers, all of this kind of stuff. So much nightmare associated with it that almost nobody really built these beautiful, highly available applications. And one concept that was really important in moving from this old world of IT to the new world is that all your resources should be programmable. These servers that you see there, they're not programmable, they're just physical. You have to, if you want to do something, you have to walk over to them, you have to pull the plug. If you want to move applications, there's a ton of work to be done. The new world of IT, everything should be automatable. That's what's going to help Greg in actually becoming a very smooth DevOps operation, because all of these things are no longer physical, all of them are virtual. Yeah, so on one hand, you have the regions around the world. You want to decide whether you want to run your main application in Singapore, but you want to back it up into the Tokyo region, so that you can restart from there if that will be necessary. Within these regions, you've got these availability zones. All of those are programmable concepts. You have them at your fingertips. They are available for everyone. It doesn't cost you anything more to use more than one availability zone or more than one data center. It comes with the package. Yeah? And on one hand, we give you a whole range of services that can by themselves already make use of the multi-AZ capabilities, such as S3 and DynamoDB and RDS. If you look at the magic that sits in Amazon S3, which is the simple storage service, under the covers, it does on a daily basis trillions and trillions of operations, dealing with all sorts of hardware failure scenarios where you will never get exposed to, because this service is so rock solid that you can always rely on it. Last time I compared it that, I'm so excited by this simple service that I almost would like to call it the ninth world wonder. Yeah, I was a little bit biased there, but okay, fine. Yeah, DynamoDB eventually will be number 10. Yeah, and why not number 8? Because there's so many people fighting for number 8. We'll leave that to others. Yeah. So it's such a beautiful service. It's so that simple. The fact that you can drop objects in there and they are HTTP addressable. Yeah, we have people seen building great, highly reliable architectures because suddenly they do pre-formatting of their objects in HTML. They just drop it in S3. The only thing you need to do is use some JavaScript and do some delayed loading and get your HTML directly out of S3. It is a magic service in that sense. And then, of course, we give you building blocks to build your applications with. And EC2 is, of course, the core building block, but again, this is a programmable service. You want to build highly available algorithms or have all of these enterprise architecture patterns that you would like to execute on, you can, because you no longer need to move hardware servers around. And so we have a whole section on our website, which is called the Architecture Center. It is aws.amazon.com/architecture, and there's all these different patterns there ready for you to use. Yeah, and actually, quite a few of our solution architects that are here today, you'll find them out in the room later, will be happy to actually modify these particular architectures for your particular service or your particular problem that you want to address. All of us know very well how you can now use these building blocks to build these great services. Some of our customers push this a little bit to the edge, and Netflix, a large customer of AWS, has built a component called the Chaos Monkey. What does the Chaos Monkey do? It randomly shoots components on the platform. Yeah? So they are running many EC2 servers. Chaos Monkey rolls a dice, kills off a particular EC2 instance, with the idea that the software that they've built should be survivable under all circumstances. And this is a great service. And actually, the great news is that they've promised that they will be launching the Chaos Monkey as an open source component pretty soon. Yeah? Actually, I would like to invite Warren Siva on stage from Vodafone Hutchison, who's going to talk about the application that they've built for Vodafone Cricket.
Good morning. I'm here today to talk to you about the Vodafone Cricket Live Australia application. Now, before I get into it, can I get a show of hands of those cricket fans out there? I think the Melbourne crowd beat you guys, sorry. Okay, you're going to find this interesting. Now, just a bit about Vodafone Australia. Now, we are operated by Vodafone Hutchison Australia. Back in 2009, there was a merger where Vodafone Hutchison 3G, 3Mobile, merged, and we now operate 3 brands. VHA operates the Vodafone brand, the 3Mobile brand, and Crazy John's. In total, we've got about 7 million, a bit over 7 million services running here in Australia. Big Brother 2005. Now, as I was saying earlier, VHA merged with 3Mobile, and it was actually from the 3Mobile side that we got a lot of experience with live mobile streaming. 3Mobile had a great relationship with the Big Brother reality TV program. These were the early days of reality TV, and the 3 network was 100% 3G, hence almost all its devices could stream video. Now, we had 7x24 live coverage within the Big Brother house. But the real learning here was at the end of the telecast via television, the host would actually close the program by saying, you can now continue to watch the happenings in the Big Brother house via 3Mobile. And it was at that very moment we saw our traffic explode. Now, I'll be honest with you, the first year we did not cope. The second year we got a bit smarter. We had some rules on the load balancers and firewalls to shed the traffic towards a static page, informing customers, look, the house is full. But the reality was, we never really solved that problem elegantly and cost effectively. Fast forward, 2011. We went all out with our cricket series. For the last 6 years, firstly 3Mobile, then Vodafone and 3Mobile have been telecasting live via the mobile services, the cricket series. Now, last year we went all out with iPad, iPhone, Android, tablet applications, streaming, scores, and the most innovative service we've put forward with our supplier, iPowwow, the Vodafone Viewers Verdict. Huge success, immense traffic. We were clearly doing things differently. This slide here is to indicate some of the stats that we locked in. 700,000 app downloads, 4 million viewers, visits, 500,000 streams, 10,000, we peaked at 10,000 live streams and 1,000 transactions per second. We were so confident with the availability of the service and the capacity of the service, we actually opened it up to all the mobile providers and ISPs in Australia. Clearly doing things differently. This chart here is just to illustrate the nature of the traffic. One of the challenges with the service is we've got 5 days of immense traffic hitting our services, then about a week of downtime before the next cricket game kicks in. So the real challenge is, how do you manage this peak load cost effectively? The solution? Using cloud infrastructure. A combination of a content delivery network underpinned by cloud computing infrastructure, and in our case, with Amazon Web Services. So just a high-level illustration of the architecture used to support the Apple products. Using the iTunes platform for charging, a content delivery network to serve up the streams and take the first front hits, underpinned by Amazon's solution, where we've got EC2 services and a database pulling scores out of our various providers. The architecture we've used for the Android platforms, very, very similar, slight modification on the charging environment and the streaming, given its RTSP. We've used our own services. To give you an insight into the components we've used with Amazon, 2 elastic load balancers, multiple EC2 instances. We've started with 3, and this point's important, with the auto-expandable capability to burst into more EC2 instances as the traffic kicks in. Auto-scaling, another key point here, which provides redundancy within the infrastructure. We actually got a lot of help from our contracted partner, ProQuest. You need to engineer your systems. Using the cloud doesn't remove that responsibility to engineer your infrastructure to get the right performance. And through ProQuest, we actually were able to optimize the system to get us the right performance levels required. So to summarize, key learnings: to deliver a service which is low frequency, high demand, cloud infrastructure is our solution. A combination of a content delivery network underpinned by web services, cloud computing infrastructure. Moving forward, our next steps with Amazon, we're taking our unified content management system into the cloud. This is our intention here is to provide a content management system that is device agnostic, whether it be a smartphone, a tablet, a desktop, or a TV. We've got components here already in production, and we intend to take this a lot further. That's all I have for today. Thank you for listening.
Great story. I think part of distributed architectures are the ability to scale up at any time that you would want to. Yeah, I think the fact that these resources are available at your fingertips and indeed purely programmable. You bring them up, you bring them down whenever you want to. Actually, the old world of IT was just as relevant for Amazon.com. Yeah, before we had these cloud services available, before Amazon.com ran on the AWS platform itself, we were confronted with similar challenges. Now you can imagine that there is a high and lows on the daily traffic to Amazon.com, and traditional sort of capacity management dictated that you would have about 15% over peak capacity ready for you in terms of hardware. And we thought really, we're really good at actually managing hardware. But if you do that on a daily basis for a week where the whole week looks more or less the same, if you manage that well, you waste about 30 to 40% of your capacity just because it needs to sit around the whole time. But as you can imagine, in the fourth quarter of the year, in the holiday season in the US, the peaks are getting extremely high, multiples of what we would normally see during a daily session. If you then apply the same rule for 15% over peak in terms of capacity, for the month of November, we would be wasting about 70% of our capacity, because just to deal with these enormous peaks. And it's not just for the month of November, because of course I will be rolling in capacity already in October and in September, such that the teams could be starting to experiment and do load testing on them. These are, enormous amounts of waste if you cannot do it on a dynamic world. So the new world of IT for Amazon.com is also, now that all the websites have moved over to running on top of AWS, is that we can scale on a per node basis. We shed capacity when we no longer need it, and we acquire it instantly when the site is growing. This is tremendous cost savings for a company like Amazon.com as well. So transformation number 2. I think the old world of IT is probably, in terms of security, best described by this picture. And we already knew that this was not a highly secure environment. If so, we would still have moats around all our cities. We don't have that anymore. Each of your houses is secured by their own security system. And so there's a similarity with that in the new world of IT as well. We have always known that each application's security system will be dedicated to that application itself, because they have unique requirements. And you need that flexibility to achieve the exact right level of security for your application. And so there's 2 benefits to the story of how cloud provides security. And Steve Schmidt will go into that in great detail later. But on one hand, you will be able to get benefits from sort of the shared security infrastructure that Amazon offers you. Many of you, especially if you run in smaller colo locations or don't have the extensive compliance group to get all of these security compliance regulations ticked off for you, you will not be able to achieve ISO 27001 compliance, or you'll be struggling with even getting PCI DSS requirements for you. All of this stuff comes for everyone. So all of you get this very high level quality of standard security and auditability on our platform. And next to that, we give you a whole set of tools where each application can actually build security in from the ground up, exactly as it is needed for your particular application. This is a real transformation from a world where the moat and the firewall is where you rely on, versus that you're able, actually, that everyone is able to secure their own house. So the third transformation is actually is an interesting one. I understand the HOF is really popular in Australia. Although this picture is more out of my youth, and when HOF would actually be communicating with Knight Rider, he did it in a pretty interesting way. He wouldn't actually, hit the gas pedal, move next gear, stuff like that to go faster. He would just tell the car to go faster. And Knight Rider would do that. And that's actually sort of a way that you would really like to communicate with your systems. Not through a natural language interface, that's not what I meant. But if you look at, for example, a modern NoSQL database, you've decided that key value store is really the one that you want to use. It still means that you actually, whether you do it on premise or whether you do it in the cloud, you need to have all these servers, you need to actually install the software, you need to manage it, you need to configure and tune it. That's actually pretty hard. If you look in Silicon Valley at the moment, on the top of almost all job boards is a request for NoSQL DBAs. It actually turns out that it is pretty complex to tune and manage your NoSQL system. And then you have to shard and repartition as you grow, all these kind of things, and then you grow more, and you have to go back to the beginning, all of this kind of stuff. And why? Why do you do this? Because there's actually only one thing you want from this system. You want to get guaranteed performance. You just want to tell the system actually, darn, I need for my application, I need 10,000 writes and 100,000 reads a second. That's how you want to communicate with the system. Just like that, Hoff was able to talk to his car and say, go faster, and not having to tell it, shift gear, push the pedal, turn left, turn right. He could just communicate with what he really wanted out of it. And the same goes for DynamoDB. DynamoDB is a system where you just tell what you want it to do. And so let me show you a little video that probably conveys these concepts much better than I can.
When you're building an application, you want it to run fast, and you want it to stay fast as your business grows and more people use your app. Databases have always been one of the biggest challenges in scaling these applications. Most databases just weren't designed to match the scale and performance needs of modern apps. As more and more people use your app, and you add more and more web servers, the database layer often can't keep up. It gets slower and slower and sometimes fails, taking your application down with it. You can try to get around this problem by building a large cluster of databases. This can work for a while, but it's hard and expensive and requires a lot of expertise. You have to make sure your database keeps running and data isn't lost, even if one of your servers goes down or there's a problem with one of your data centers. You have to know what to do if your application grows so fast that your cluster is no longer big enough. And you have to make sure your databases are running the latest software and be ready to patch or upgrade this software without shutting down your business. What if you could replace all this complex software and hardware with a database service designed from the ground up to support the low latency, high throughput requirements of today's high-scale applications? Introducing Amazon DynamoDB, a high-performance, non-relational database service built for the cloud. DynamoDB is very easy to use. You can forget about all the problems that come with managing your own software and infrastructure. That's because DynamoDB isn't database software. It's a database service that handles all of this for you. You just tell the service how many requests it needs to be able to handle per second, and it does the rest automatically. Then, when your application really takes off, and your database now needs to be able to handle thousands or even hundreds of thousands of more requests, what do? You just dial in the scale that you want, and that's it. We automatically spread your data across enough hardware to provide consistent performance and to protect against downtime. And Amazon DynamoDB isn't just easy to use, it's also really fast. Instead of using traditional hard drives, your data is stored on solid-state drives for fast access to your data. In addition to being fast, DynamoDB is also extremely reliable. We automatically replicate your data across multiple AWS availability zones to protect your data and to provide high uptime. Plus, DynamoDB's synchronous replication architecture protects your database from hardware failures in any individual node. And you can get started with DynamoDB for free. So when you're ready to take your database to cloud scale, visit our website and sign up for the free tier of service today.
Thank you. One thing that I've already seen with quite a few of the customers that are using DynamoDB, that the performance of DynamoDB is such that suddenly the bottlenecks start shifting. Yeah. In the old world of IT, often the bottleneck, or often, in 95% of the cases, your scaling and your reliability bottleneck would have been your database. But if you now can configure the database to have exactly that performance that you need, suddenly that bottleneck shifts toward the application. I remember that some of the first beta customers that we were having on the DynamoDB platform, they would configure 300,000 writes a second just to load the database. And immediately, the complexity shifted towards the application, the way that they were using their threading, the way that they were using caching, and all of these kind of things. I've seen quite a few architectures already where the whole caching layer just disappears, because suddenly the database is fast enough and actually really performs at the level that you want your database to perform consistently. It's not that these numbers are actually fixed. Yeah, if you want to switch down to a lower throughput model at night, those are things that you can absolutely do, or you can scale it up if you anticipate more of your customers coming on board. The fourth transformation is also one that is pretty significant. I think, if you look at supercomputers used to be the realm of the elite. Yeah, if you almost nobody was able to afford themselves a supercomputer, and if you could afford one, next to, of course, the big research centers that have these massive grays and things like that, most organizations would have what I would call a departmental-sized HPC system. And most of those systems actually are so expensive that they have to be loaded up 100% of the time, all the time, for 5 years. Yeah? Because that's actually how long it takes to pay off a system like that. And it also means that, you know, to get your job inserted whenever you need it, you're on the waiting list. It also means that after 3 years, you're actually running on pretty old hardware. And so our goal with bringing high-performance computing to the cloud was to put a supercomputer in the hands of every developer. Yeah, so we've delivered 2 different versions already. The second version, when we launched it, we just threw a bunch of those nodes together and immediately became the 42nd fastest supercomputer in the world. And this is actually capabilities that is available for everyone to use. And actually, we could have probably done much better if we would have added our nodes with our GPU boards in it as well. GPUs are graphic processor units originally designed to help you do great gaming on your PCs. Now they're actually boards that are really, really smart in doing very fine-grained parallelism. And there's something called general-purpose GPU programming that has great promise. But most enterprises and most companies never really could afford themselves to invest in GPUs because that was a world that was still very much in flux. So we've added to our first generation of HPC nodes 2 GPU boards that allows customers now to experiment with this very fine-grained level of parallelism and achieve enormous speed-ups in their HPC workloads. Most of the, let's say, the top 20 of the top supercomputers in the world are all combinations between CPUs and GPUs. And you can expect from us that we'll continue to provide the latest HPC hardware for you to build your own supercomputers. A customer that has done great work on this is a customer called Cycle Computing. They are looking at how can we really build very large systems in the cloud using these capabilities. And one company that they were working for is Schroeder, who is a leading developer in computational chemistry. So they basically do cancer drug research. And most of these algorithms are actually pretty brute force algorithms. Yeah, you have more or less you have a lock and you have 20 million keys that you need to try whether that one fits in one of those locks. And normally, one of those test runs for them would kind of take a month or 2 to complete. And here, it is something like in drug research, cancer drug research, every day counts. The faster you can move, the faster you can get new drugs in the hands of patients. Yeah, so Cycle Compute built a 50,000 core supercomputer on top of AWS. Yeah, and they ran this for 3 hours. They needed it for 2 hours to actually get all the 50,000 cores up and running, and then for 1 hour ran the algorithm. And in this 1 hour, they did as much work as normally would have taken months on-premise of the customer. And the on-premise architecture would have costed them $20 million to instantiate. In the cloud, this costed them $5,000 an hour. So for $15,000 in total, they did a drug trial run that ran more orders of magnitude faster than they would ever be able to do on their own platform. The kind of advances we can see in medicine and in e-health because of this, because of these massive capabilities to be available, will really change the way drug research is being done. The fifth transformation we see from an old world of IT to a new one is more on the business side. Yeah, I think most of you, if you're in business, you know that it doesn't always look too good these days. Yeah, there is an abundance of products in the market. There is murderous competition. Consumer choice is extremely powerful at the moment. There is a decrease in customer loyalty. And most of our organizations are actually lacking capital at the moment. So you cannot afford to start building products for 2 or 3 years, and then when you launch that product, find out that actually none of your customers really is interested in this product. So you need to get products in the hands of your customers really quickly, yeah, in a matter of months, and then iterate with them very quickly in a direction where you think this product is going to go. So actually experimentation becomes a very important tool, but in the old world of IT, this experimentation was extremely costly. Often millions of dollars. Well, if these high costs are associated with experimentation, you'll think twice before you do it. In the new world of IT, experimentation is dirt cheap. We are talking about hundreds of dollars, or maybe thousands of dollars that you spend on actually trying to get a product in front of your customers. And then looking at where am I going to take this? Is it becoming successful? We take it in this direction, but we're never hampered by the amount of resources that we have. So it allows you to move really fast and to really get products in hands of your customers very quickly and take them in a direction where they wanted to go. And Richard Durnall from realestate.com.au, they are specialists in doing this the agile way. It's going to talk to you about that.
Hey guys, so you probably know the realestate.com.au URL and the brands that we have within Australia. We also run leading portals in Hong Kong, in Luxembourg, in Italy. So everything that we do, we come up with really a global view. As Werner's mentioned a few times today, there's definitely an old world view of IT and technology. And 3 years ago, we were definitely in that place. Our core applications and platforms and products hadn't been released in a long time. They were very difficult to work with. Release cycles would often take us months to be able to get anything that was actually built into production, let alone the time taken to actually build a new product. So the last 2 to 3 years, we've really set about rebuilding the way that technology and our product development works in REA. So we knew from the start that we wanted to move to really highly collaborative, team-based models around the way our products and our services were taken to market. And we spent a lot of time reinvesting in IT and moving us into a different delivery model. So back in the old world, we were competent at doing one thing at a time. We could move one product through the pipeline at any point in time. With the pace of innovation and growth, and us being a high-growth.com, that wasn't going to work for us in the new world. So we had to get to a model where we could run multiple teams in parallel on the same applications and products to take new ideas to market simultaneously. So today we have a delivery organisation that's distributed across Melbourne and China that are working on multiple pieces and pumping them to market in parallel. And to do that, we used a lot of the Amazon services quite heavily. One of the things that we needed to do was be able to build environments in a similar way to Craig mentioned this morning, really quickly for every developer and every development team. So we built a lot of tooling around the Amazon EC2 product to be able to spin up a dev test ecosystem of our full environment really, really quickly. So to put it into context, over the last two years we've done a lot of work so that today, if you're an engineer in REA, you can hit a button, you can walk away for 20 minutes, make a coffee, come back to your machine, and 91% of the time you'll have a complete REA ecosystem sat in EC2 ready for you to do a new product or project with when you get back to your desk. We also invested really heavily in our continuous delivery pipelines. So continuous delivery is the concept of, as a developer, when I check in a coding change, my code is immediately built into the application, it's tested, it's promoted to the next stage of the world where other coders tests from my application are tested with it, plus other changes from other applications in the ecosystem, up to a point where a product manager can go to a screen and look at a dashboard and say, I actually want to change take all of those changes to production, push a button, and those changes are automatically promoted into our production environment. Now, we're not there with all of our applications and products today, but a core of them are there, and we're moving the remainder of them to that model over the next 12 months. So one of the big symptoms and side effects of doing that for us is really about helping us drive innovation in our business. So we do hack days every 3 months, every quarter. They're actually happening today and tomorrow in Melbourne. And one of the side effects was that if I'm working on a hack day project or just projects in my own time and I want to experiment, I can just go to a dashboard, push a button, and I've got a full ecosystem available for me to play with in EC2 in a very short period of time. So I can experiment in a sandbox, try ideas, try new products, new ways of working, do that really quickly. The other side effect here was that if we're about to do a new project, a new product, we can get an indication of what work is required really quickly. So generally today, the first thing we do when we have a new project idea is we spin up our environment in EC2. Let's say we're planning on putting our sites and products into a new region. We spin up the Australian ecosystem in EC2. We throw that country's data at it, and we just see what happens. And it gives us a really quick indication of the work we need to do and the size of the work. The great piece for us for the next stage of the journey is that we're very into the lean startup model as promoted by Eric Ries. The idea of being able to put new products and ideas into the market incredibly quickly, be able to measure everything in production, and be able to respond to the behaviours of our customers and consumers incredibly quickly to improve the products. It's the idea of who can adapt the quickest will win. So we're putting this idea and these technologies into all the products that we're building going forwards. And the real example of that's our archetype. You can go and see it on our realestate.com.au tab. You can go to Home Ideas, which is a product that we built recently to allow people that are looking at renovating their home to get ideas on kitchens, bathrooms, those pieces. And we built this through the model that I just mentioned. We built very quick dev test environments using EC2. We built deployment pipelines that chain all our technologies, all our tests, all our environment stages together. And the team on the Home Ideas project will typically deploy multiple times a week, and at the moment are typically deploying multiple times a day. And they'll come up with theories to test that they think consumers will behave in this way. They generally don't, we find. It's really difficult to predict what will happen when you hit the real world. But they'll pump out a change in the morning, monitor really heavily what's happening with that change, and they may make a change again in the afternoon or the next day or the day after to really affect where that product goes. And so this is the archetype that we're moving to now. It's made a huge difference to the ability of our organisation to move quickly and innovate. Thanks.
Moving fast is definitely part of the concept. I mean, it's one of the things that I think we pride ourselves really, really well of in helping others actually get to market with new ideas really rapidly. I think part of the lean concept and also part of the experiment quickly, the philosophy is that you should measure relentlessly at the same time. Yeah, you should actually get lots of data about your customers, about your operations, and then do analytics on top of them to see whether you are doing the right thing, whether your customers are liking your product, and you should actually really invest in that. And at the end of the day, I'll give a longer keynote on something that's called data without limits. I'll talk about many of the concepts of how big data and cloud actually play very closely together, and I'll talk about lots of use cases there. One of the things actually with big data is, although it's a relatively new concept, at least how let's say how the press is talking about it, there is already a relationship between old and new. In the old world of IT, you were very, very hard pressed to be able to do anything with big data. There's a company I'll talk about this afternoon called Razorfish. They were an analytics company. But in reality, these guys were becoming a storage company. The best people were actually working on storage because they were collecting that much data that they were becoming storage architects. And at one moment they said, well, enough is enough. So they moved into the cloud so that they could actually spend their best time on developing better algorithms, instead of focusing on storage. Yeah, and that's how it should be. It should be that simple. You should be able to move your data somewhere, not actually having to think about how much data is there. You want to fire up a Hadoop cluster yourself? Do you want to actually not having to do with the muck of all of that Hadoop stuff, but just want to run the algorithm? You can make use of Amazon EMR, and you should have tons of easy tools to just share your results pretty quickly. It should be really simple, instead of being hampered by all these infrastructure pieces. But I think Seth Yates of Brandscreen, their CTO, is much better suited to talk about that than I am.
Good morning. Good morning. I just want to share a bit about Brandscreen, our big data challenge, and how we're solving that with Amazon Web Services. When we first started Brandscreen, we started with 2 key insights. Number one is that the way that online advertising is bought and sold is broken. If you're a media buyer, the traditional process would typically go something like this. You'd get a brief from your client. You then look at your ratings data from Nielsen or Comscore. You would then try and build a media plan which would hit a majority of your audience. So you might say this media plan hits 54% of the people I'm looking for. Well, there's 46% that aren't in your audience. Once you've got that media plan, you then would go out to publishers and you book in a media plan with them. You would negotiate back and forth. You would send a proposal back. Negotiation ensues, and eventually, weeks later, you get your advertising online. So basically, it's very inefficient to actually get your media plan actually going. The second key insight was when you actually look at it, online advertising is a commodities market, and what was being executed were basically forward contracts. So the thought here is, what if you actually change this from a forward contract market to a spot market, where you actually traded online advertising in real time as it happens? So as you go to a web page, actually making a decision, do I take this impression, which ad do I deliver, and how much do I pay for it? Now when you do that, you actually have 3 very hard challenges that's involved in that. So you have to have a very low latency. So as you're making this decision, as people's web browser is loading the page, you have to do a decision in milliseconds. So literally milliseconds. Because of having to view all of the ad impressions that are out there, we're seeing about 5 billion events a day. You have a very high throughput. So in every minute, we're seeing 7 million ad impressions. Over a day, again, we're seeing about 3 or 4 billion ad events, which generates a lot of data. So it generates terabytes of data per day. If you actually look at the amount of data that we have actually stored on Amazon S3 right now, the raw log data is approximately one petabyte, and that's growing 10% per month. That's a lot of data. So when we first started out, we didn't have the CapEx required to get large servers. We didn't have engineers who could plug things in, who could build large 30 to 40 node Hadoop clusters and actually process this sort of data. But we could do this with Amazon Elastic MapReduce. Simply go to the console, start some jobs, get some scripts going, and actually analyzing the data. So we don't just aggregate the data, but we also do machine learning algorithms in the cloud as well. So optimizing the advertising delivery, seeing what's working, what's not working, and actually changing the plans on the fly. So some of the key learnings that we had in this was basically experiment. I think Werner mentioned that earlier. Experiment, iterate, try different things. If what you've done doesn't work, or if you've done, just turn off the capacity. Second is learn. So go into the forums and go online, look at the online documentation, and pick up some tips to help optimize what you're doing. And lastly, plan. So just because Amazon Web Services gives you a great toolbox for building fault-tolerant architectures doesn't excuse you from actually having to think about these sorts of systems. Great. Thanks.
Yeah, that last point is a really important point. And I know some of you were here last year when we were doing our roadshow here. At that moment, John Jenkins, the director at Amazon, who was responsible for moving the Amazon.com website over to AWS, he ended up with a set of recommendations, and one of his last points was that the cloud doesn't cover up sloppy engineering. Yeah? If something didn't really work in your own data center, moving it to the cloud is not suddenly going to make it better. Yeah? You still actually, but what it does do is the cloud gives you these tools to actually make it much easier to make your application better, to make it fault tolerant, to make it secure, to make it more reliable, and definitely to make it more efficient, things that you could never do in your own data center. So there is lots of room. There's all these possibilities that come when you move your applications to the cloud, but you still have to do something for it. And so the last transformation I want to talk to you about is really, in my eyes, one of the more important current trends that we see. Yeah, in the old world of IT, when you think about building mobile applications, there's actually a lot of work that you have to do. Yeah? If I look at what is actually sort of the basic building blocks for a modern mobile application. Yeah, there's all these things that need to be included. It needs to have rich media, you need to be aware of where you are, the location context is most important, not just where we are right now, but what are the traffic conditions, what's the weather like, all of these kind of environmental pieces around your location. It needs to be able to get things out of the real-time environment, whether they're the social networks or maybe things coming from your enterprise in real time. It needs to have some integration with your social graph. User-generated content needs to be included. You need to have a recommendation engine. You need to have search. And, of course, you need to make money, which is either virtual goods or advertisement or maybe some premium services. All of these are just the starting point. If you need to do all these things, you haven't even built your application yet. Yeah? And so it's important that you actually can get all of these building blocks together and stitch them together and then innovate on top of that. The good thing is this new world of cloud helps you build these mobile applications very rapidly. And I purposely actually picked lots of services here that are coming out of the ecosystem. The ecosystem, so the Amazon cloud is much more than the Amazon Web Services. In this ecosystem sit a wealth of new services that help you build mobile applications very, very rapidly. So you need to get some location context, you use Simple Geo, you need to get virtual goods, you use Social Gold. You want to have a recommendation engine? You have some data, you put it in directed edge, you tell them what the relationships are, and they will actually, their engine will give you a recommendations back. Yeah, all of these services together provide you with a sort of the operating system for building mobile applications. It allows you to completely focus on what makes your application unique. Yeah, and such that we can really move fast on building very, very rich modern mobile applications. One that I'm actually, that I've recently been demonstrated and I'm pretty proud of is the one that actually PBS is building. PBS is the public broadcast system in the US that are known for their very, very high quality content. And so their online web environment actually has already a lot of streaming. They're streaming most of their content there as well. But they've also moved over to the mobile world. And some of their applications, they have PBS Kids in one, but also their environments for Masterpiece Theater and things like that are very high quality, very high rated applications. And if you look at the numbers, just from the beginning of this year, they're astounding. When they launched their mobile apps, so in February, 27% of the watching of online content happens on mobile devices. But more importantly is that in the month of February, that actually doubled. Because before that, it was just a little bit more than 15%. And they continue to see the doubling of actually use of mobile devices to consume this kind of content. This is kind of the real important message. Mobile is becoming increasingly important, even to the point that you should be considering mobile as your first platform before you start developing your applications. And for that, you need to have this application infrastructure and this application operating system that allows you to build these applications really fast. And I like to believe that we are delivering that with the Amazon cloud. This was the mission where AWS started off with. Yeah, this was before we knew how well we could help organizations move from the old world of IT to the new one. Our mission was to enable businesses and developers to use web services, what we now know as the cloud, to build scalable, sophisticated applications. And our mission is still that. You'll see that we are still, at our core, a very heavy technical but customer-oriented business. And I like to believe that we'll do that for a very long time to come. So